So hi everyone, thank you so much, Fabian, to invited us to present Kilonova-Catcher. So I am Sarah Antier, working at Observatoire de la Côte d'Azur in Nice, and I'm presenting on behalf on the Kilonova-Catcher team, Grandma team, but Damien Turpin is the PI from the Citizen Science program. So Kilonova-Catcher is a program dedicated to transient phenomena, high energy phenomena. So I will discuss a bit about the origin, about this birth of this program, motivated by gravitational wave science first. And then we explore now new science, so co-collapse, supernova, and gamma ray bursts associated to this. And with the horizon of Vera Rubin, more fast transient type. So this is the logo of Kilonova-Catcher, and I will come to this origin because maybe you don't know much about it. So as I said, Kilonova-Catcher was born also with the need of gravitational wave follow-up and gravitational wave science in 2017. So as Marika recall, and most of you recall, observing gravitational wave event is tough because it's not this kind of well-localized event. Also, sometimes, as you saw in 04, when we have an alert, we are not very sure about like if it is astrophysical or not. So sometimes, even if you start follow-up, maybe you follow up some noise. So there is this kind of new concept of observing the transient sky, but with large localization region, for which the community was not really prepared, or was prepared, but at some kind of deep sky. And so because we are in transient phenomena, the alert come at any time, so we need to have quick an observation ready to observe, or a Wi-Fi server that was observing as the right location of the sky. And we are in some kind of cosmological distance, so outside of the local environment and the Milky Way, and this is this event that we try to tackle with. And so in my presentation, sometimes is a bit busy, but because we have also for this Kilonova-Catcher program installed some kind of astronomical guide. For example, for the amateur, because Kilonova-Catcher is based on observing with the amateur astronomy. So we have made some guide to understand what are Milky Messenger, what is fast transient, how you're going to observe. And for example, this is the first page realized by Damien Turpin's sister, by the way, artist person, that try to educate and inform about what is the electromagnetic signature of a collision of two neutron stars. So we try to explain the different signature. And of course, this Kilonova-Catcher means that we need to catch up the kilonova signal. So we explain what is a kilonova. And there are two kinds of kilonova observationally, a red one and a blue one. And as I said, it is compact in this astronomer guide that I have also uploaded in the Indico, Fabien, so that you can have a look what we can say to, citizens. So because we have large error and we see different networks, so Korea and so on, and Assassin, so we need to have prompt observation as soon as there is a gravitational wave alert. And so after the wonderful discovery of 1717, we decided in France to merge our efforts, also with collaboration with China, because France was from heritage was born collaborating with China to merge our efforts, and then other groups, so from China to France, basically, joining to create these networks of inhomogeneous telescopes, which mean that they are not like like GOTO and so on. There are telescopes that were not supposed to participate together. They don't have the same filters. They don't have the same way of functioning, etc., etc. So it's a network with, some kind of asynchronized network, but try to look on only one direction, which is finding the kilonova or finding any counterpart associated to gravitational wave sources. So here, obviously, I think some of you know Grandma and you see the map because it is what is impressive. But in fact, multi-messenger is not only observing, it's also coordination at different levels. And the second coordination after requiring observation for all over, to map and scan the gravitational error box is to have an homogeneous data reduction when you have different filters. Some use L-band, some use Sloan filters, some use Johnson filter, because you need to have a precise photometry. So in GROMA, after having this huge work, 2018, 2019, we start really try to get ready for data reduction. So our aim is for imagine for you observer, when you upload to astronometry.net, you got the astrometry, right? And now you want just to upload your image with astrometry and just get the photometry from your source. This is what we aim for. And so for that, we have used a lot of image from different our telescopes and try to adapt this data reduction to ingest all multiple telescopes, but also the amateur. And this is this coordination that is not only with professional, but also with the amateur. The second thing, the third thing that you need for multi-messenger is coordination on the interpretation, which means a multi-physics framework, because we're talking about multi-messenger, so you need to have gravitational wave physicists, you need to have astrophysicists, you need to have nuclear physicists, et cetera, So there is this kind of coordination when you have a model that zoom on which part, for example, the ejecta, the other one of the waveform of the gravitational wave, all needs to be at once to have the global picture. So this is not about observer, but this is really a big challenge nowadays in multi-messenger that we need to face on. So observation, data reduction, and then up going to the model to have the global picture at once. And in GROMA, because we have observer and theoretician from gravitational wave neutrino and astrophysicists on the ejecta, we are trying to make this challenge also on the interpretation. Okay. So since we have done all this kind of coordination and homogeneity for the professional, we said to ourselves, after a year, why not opening to the amateur? And that's why in 2019, Kilonova-Catcher was born, based on some idea from colleagues from Toulouse, especially Alain Klotz. And so since now in 2023, we have this kind of map of amateur all around the world. So especially in France, because the project started in France. Also, you need to know that the amateur astronomer community also are not that perfect in English at Earth. And so there are some language difficulty to transmit the information. They are very good astronomer amateur, but then sometimes they don't speak well English. So there is this kind of barrier that you need to take into account to build this kind of network with telescopes. Also, because we are in time domain astronomy and we look at faint star, so not 12 mag, but more 19, 20 mag, it means that we are only have the top of the amateur community, the one that has in kind of size above 25 centimeters. Sorry, in diameter, I took 100 centimeters. Okay. And so the amateur, compared to GROMA, they are only at this coordination of observation. Then all the data analysis and interpretation is managed by GROMA, which means that if you're an amateur, you are in the Kilonova-Catcher program, but you're in some sense not in GROMA. GROMA is the kind of scientists that take care that the machine is running for Kilonova-Catcher. Okay, so because Kilonova-Catcher is really linked to GROMA, it's linked to the science that GROMA can do, of course. So there are three topics, as I said, binary neutron star and gravitational wave science, gamma ray burst, and then fast transit with Vera Rubin. And also I say number 4, so because we need some training on opportunistic sources, so supernova is not a training, but it's some kind of sources that we can continuously observe to really train the professional and the amateur. So we have a website when amateur can connect kilonova-catcher.en2p3.fr. So it's hosted in France and in En2p3 at EGC Lab. And what you can do in this website, you can register your telescopes to participate to the program, and you can have the alert that will be handled by grandma, like yes, and then you can just drop your observation. Then all the rest, photometry, will be taking care outside of this website. So I'm just checking the time. So as I said, Damien is the PI of the Kilonova-Catcher program. Alain Klotz was the founder and worked closely with Antoine Caillot, who is also a Toulousain. So me, I am the PI of Grandma. And then we have Quentin, who is a contractor and working of synergy of multiple projects and communication. And then we have the EGC Lab support also with Julien, sorry. Okay, so you need to know that there are different participants in an amateur observer program. So we have about like 100 accounts, maybe a bit more. I think we have 200 subscribers to our list, but 100 people that post a telescopes. And then in fact, 50% of this person involved provided or uploaded at once one image, one or multiple. But then 10% of the 300, so only 10, can reach 21 Mach in with filter. I don't count without filter or clear filter. And then 5% of them can also perform some photometry. This is the amateur, okay? So the idea over years, because it's a course de longue haleine, so I mean long-term program, we would like to reach more. Either we attract more person, either we need to upgrade the skill from the bottom to the up. But since 2019, 700 images have been uploaded, I mean, in total in our platform, and 70% of times valid, which means that we can extract some photometry associated to this. And nowadays we are trying to transform a bit, I mean, to fit more the professional, and we have provided 6 set of Sloan filters. So a set of Sloan filters is about 500 euros. So just 6 is already a bit for the amateur, the one that's uploading most of the image, so that we can compare with Pan-STAR. And we hope to provide more and more sets. So it's borrow, okay, because it's on CNRS, but it's borrow to the amateur. So really to help us to have this calibration in photometry. Okay, so how to get in an alert if I am an amateur astronomer? So I connect to the website, or I can have in via Slack, because we have Slack. And what I see in the portal in my email is like, for example, I have a gravitational alert. We set up like a time, a countdown to say, hey, okay, you have, 1 hour. 1 hour is it's a bit a race, but normally 2 days to perform, for example, your galaxy targeting survey, and then go. Okay, so the pointing that you have provided for a gravitational wave follow-up is done by Sky Portal that just Théophile presented, and we just redirect to the website of the amateur. So why? Because this is for professional. This is very messy, a lot of features, as Théophile said. And so we need a special website with some kind of view that the amateur likes. That's why we were needed to have another website to have features that amateur understand, I like, because we just remember that amateur are not paid by us. It's the activity, leisure activity, so it needs to be fun, and we need to motivate them. So the galaxy provided, for example, for gravitational resources for each amateur are not the same, and we are distributed regarding the location of the telescope, because we know the location of each amateur telescopes. And this sharing observation plan is done by a GOAMOP, and maybe the upgrade version of M4Opt that is running by NEVA. Okay, so I talk a bit about this at the introduction, the standardization of the optical image analysis. So it is done for Kilonova-Catcher and for the professional grammar. So in fact, for all exactly the image no matter what, if it is professional or amateur. We go through astrometry.net for or any kind of VIX for the amateur. Then we apply some mask, automatic mask, vectors cosmic, etc., etc. And then we have this kind of web platform that we can, if we can press the button, we have automatically some kind of upper limit and some photometry. So this web service, which is private for the moment and is also hosted at IGC Lab. So take into account, for example, automatically recognize, in the header, for example, the filter or not the filter. So we choose, for example, either Gaia for a broad filter or more pan-star, and recognize the time, etc., so that we can have directly the photometry. So then, whether or not there are amateur data, so for example, for this kind of GRB and then above of the supernova, someone talk about core collapse supernova. So this is exactly an example of August. So the amateur, we provide basically some data points, at the beginning, because at a certain time they are limited, and then Grandma is gonna follow up. And sometimes they provide for this supernova, for example, because it's rebrightening, they have provided data at the time of the bump. So all the data are mixing. So I cannot tell you which one is amateur or not. I just know that the trend is okay-ish. And then we run some modeling. So in Grandma, we have put a lot of energy of GW science and collision of neutron star, black hole. And we are trying to develop our axis on more collapsar with EAP colleagues. Okay, so now connection with other, Astro-COLIBRI and Unistellar. So since about 1 year, 2 years, we are trying slowly to make the connection with Unistellar, who have this capacity to have a large networks, but for the moment not reaching the enough sensitivity for GW science, because we measure with 30-minute stacking image, so it's about 450 images. So when you stack too much, you have always some problem of mis-coating, and then it creates some blur for the photometry. But anyway, we measure that for an interstellar telescope, we can reach 17.5 sensitivity in broadband filter or CLIS filters. So this is what we aim for. So for example, Unistellar, we provide science, for example, for gamma ray bursts, maybe supernova, but for the moment, a bit too faint. Or we need to add more and more amateur on the OB scope to reach the sensitivity. Or maybe it is too close. Maybe it is a galactic supernova. You don't know. But Unistellar is really in partnership with them to improve this transient domain. And so I think over the next years, there will be more participation from Unistellar. And so Unistellar have access to our Sky portal, have access to the source that we are observing. So if it is in their sensitivities, they can go directly amateur to that. For Astro-COLIBRI, then we don't have official partner or official feature one to another, but what we have discussed in January with Fabien was to say, okay, this source is followed by Grandma, because if a source is followed by Grandma, generally there is some kind of paper, or for sure some reports officially somewhere at the GCN for that. Okay, so some kind of, because we talk about amateur and observation, so I would like to show you some observation from the amateur. So there are two gamma ray bursts. One, as I said, in August, taken by Michael Friber, and the other one by Denis Marché, and we clearly see the new source, which is an afterglow on it. And we helped with this beautiful image to propagate to other amateur and so forth and so on in other countries than Europe, to making grow this amateur community. And also, as I said, we have some kind of role to educate people to multi-messenger astronomy, because usually when you observe with your telescopes, you're not in the middle of Paris. So which means that you can be a vector of science, to promote, okay, I have done that, this is useful for the science. So we have done some kind of podcast in our YouTube to explain our science very easily and also in different language. Okay, so Fabien, I have like 10 minutes. 5, okay. So I just will skip, but I would like to go into detail about like the gravitational wave. So for example, this is the view that we provide to the amateur in our website. So you see it's not the banana shape that we have for GW to make them more understandable. And we are taking care of the characteristics, so not to give them a source that they cannot observe, the location, observability, et cetera, for gravitational science, but also for all the sources that we provide to them. And they have participated, so in 03, to the observation of galaxy compatible with GW sky search, for example. This is Kilonova-Catcher, seen by Kilonova-Catcher people. But also in 04, they have also observed some galaxy during 04. And you know that there is no detection yet of counterparts of gravitational wave. Second subject is gamma ray burst. So here we are some kind of unofficial, but finally it's natural collaboration with them. And we have trained both Grandma and Kilonova-Catcher to respond to a gamma ray burst trigger, not only one day and then this is done, but to have continuous week of be ready for a gamma ray burst. And this was a training just before 04 of F week, and we can see that with Grandma, but also with Kilonova-Catcher, we can reach a sensitivity and sensitivity at the adequate time to observe gamma ray bursts. And we know that, so quantitatively, continuously during 8 weeks, but also because we have also observed some particular gamma ray bursts. When some of our colleagues say, oh, this is nice, you need to observe, but because we are always ready, right? Because we are ready for GW, we can trigger Grandma and Kilonova-Catcher at the same time. And these are the amateurs that are in our paper submitted to referred article for 3 kind of journey. And so this is not only like amateur, oh, I report in GCN. No, this is about like co-authorship in an article together with the scientists. And in Grandma, we have some kind of alphabetic order, so it is mixed. And so, and you're there as well. So this is the name of the amateur that participated. And so number 3 is a fast transient. So 1.5 years ago, something like maybe 2 years ago, I mean, time runs so fast, we are preparing for the fast transient exploitation science of Vera Rubin. So of course, since I mentioned EGC Lab a lot, is because we have this connection of EGC Lab. And so there was Julien and his team preparing for Vera Rubin and Think, and we said, okay, why not we collaborate? So we built some fast transient channel. Of course, now we are open to new brokers, but at the time it was more, back and forth. Okay, how are we gonna do that with voice field, with Think? And so Think was training on Zwicky Transient Facility, still there. And so it's import to Skype to Grandma some kind of interesting fast transients that can be kilonova without GW. And we follow up them with Grandma and with Kilonova-Catcher. So among these 12 Alex, we follow up 6. And so there was no kilonova, but it was supernova and so on and so forth. And so this is one of the contributions for Vera Rubin fast transient, because as you know, you have a problem of, I mean, it's not a problem, but the cadence is slow and sometimes too slow for fast transient. And this is what we have. We can say we have, in purple, for example, see the light curve of DTF with some kind of cadence. And thus we are able to filter between the points. And so this is what I ask Jacob to you, is how to then use all the data and put another filter. And I don't have the answer. So at the conclusion, this is where we are after 4 years. So the number of participants has been multiplied by 4 because we're starting by 30 people at the beginning. We have diverse our source, so not only W science, but gamma ray burst for Zon and fast transient for Vera. Gravitational wave is still the core main program, and we hope that amateur will catch the kilonova, right? We have, with amateur named Far Referee publication in 2019, And yeah, we have proof also to the world that amateur can reach 21 mag in color. So it is because sometimes people do not believe me. And then we are trying to instrumentalize amateur to fit more our professional requirement, for example, to bring them sound filters. And thank you so much.